Hi, Assalamualaikum. We from A4AS12028. Today, we would like to present about fluid in motion and quantity equation, Bernoulli equation and its application, viscosity and Bernoulli law.
Hi, my name is Mirza Irdina binti Mazlan.
My name is Nur Fasiha Hidayah binti Asri.
My name is Nur Hafizah binti Gani.
My name is Nur Natasha Nirsha binti Abdul Halim. First, what is a fluid? A fluid in physics is any liquid, gas, or other material that continually deforms, which is flows when other external force is applied. There are substances that are unable to resist any pressure applied to them.
Next is the problem. The first problem is to find the appropriate application for fluid in motion, Bernoulli's equation, viscosity, and Bernoulli's law. Second, to find out which fluid mechanics suitable to solve the problem that related to fluid.
Fluid in motion is a part of fluid mechanics and deals with fluid dynamics. In motion is mass flow rate, volume flow rate, and equation of continuity. Fluids can move or flow in many ways. It may be smooth and slowly or violently. For example, water flows violently over a waterfall. Its name goes to raging tornado. The air forms a raging tornado. Next, water in canal, which water flows smoothly and slowly. It also goes to breathing. When you breathe in, you move a diaphragm that lowers the pressure inside your lungs. Higher pressure at outside your body is sucked into the lungs to fill the gap. Next, smooth and consistent fluid flow is called as streaming or laminar flow. Other than that, when the velocity of fluid particles at a given site changes as time passes, there's an unsteady flow. When the flow reaches a particular speed, it becomes turbulent. You can see from this picture. Let's move to laminar flow like I just said before. Laminar flow has smooth and steady flow. The fluid particles that pass any point follow the same path at the same speed. Since the fluid is not viscous, there is no friction between the layers of the moving fluid. This is the mass flow rate, which is the mass that passes a given point per unit time. To find the mass flow rate, you have to times fluid's density with cross-sectional area and fluid's velocity. Next, continuity. As long as no fluid is being added to or removed from the system, the mass flow rates at any 2 points must be equal for that to be steady flow. Equation of continuity is density 1 times with cross-sectional area 1 and velocity 1 equal to density 2 times with cross-sectional area 2 and velocity 2. If the density doesn't change, it is normally for liquid. It will simplify to A1V1 equal to A2V2. The AV, which is, A is cross-sectional area and V is fluid's velocity, represent the volume rate of flow. It is also can write in Q over T. V is velocity and Q is volume. The velocity is small when the cross-sectional area is big. The velocity is large when the area is small. And the flow is lower when the pipe is larger. Now, let's move to the example. Water runs through a water main of cross-sectional area 0.4 meters square with a velocity of 6 meters per second. Calculate the velocity of the water in the pipe when the pipe tapers down to a cross-sectional area of 0.3 meters square. So, in this question, we don't have value for V2. We need to find the value of V2 using the equation A1V1 equal to A2V2. Substitute the value in the equation and you will get the answer, which is 8 meters per second.
Next is Bernoulli equation and its application. The meaning of Bernoulli equation is when the velocity of a fluid is high, the pressure is low, and when the velocity is low, the pressure is high. So there are some application of Bernoulli's principle. The first one is airplane wings and dynamic lift. When the speed of air over the top of the wing is high, the pressure is low. And when the speed of air over the bottom of the wing is low, the pressure is high. So the different air speeds and pressure on the two surfaces of the wing make a lift on airplane wing. Next application is sailboat. The concept is same like airplane wing, which is when the volume of the air on the leeward side is low, the pressure is high, and when the volume of air on the windward side is high, the pressure is low. Meter can measure fluid flow by measuring pressure differences, including blood velocity in arteries. For the Bernoulli formula is pressure 1 plus with pressure of fluid 1 plus with 1 over 2 density times with volume 1 square equal to pressure 2 plus with pressure of fluid 2 plus with 1 over 2 density times with volume 2 square. So there are two conditions. The first situation is when fluid at rest. The V1 and V2 are 0. The equation is changes of P equal to density times with gravity and times with H2 minus H1. Next situation is when the fluid at horizontal pipe. The H1 is equal to H2. So changes of P equal to 1 over 2 times with density and volume 2 square minus 1 over 2 times with density and volume 1 square. So the example given is, water enters a horizontal pipe of non-uniform cross-section with a velocity of 0.6 meter per second and leaves the other end with a velocity of 0.4 meter per second. At the first end, pressure of water is 1,600 Newton per meter square. Calculate the pressure of water at the other end. The density of water given is 1,000. So the first thing we have to do is list all of the information from the question. We want to find the pressure of 2. So the formula we use is from the situation when fluids at horizontal pipe. The next step is you just have to put all the information to the equation and you will get the pressure 2 is 1700 Newton per meter square.
Viscosity. Definition: real fluid have a certain amount of internal friction. So, what is viscosity? Viscosity is in both liquid and gases, and is essentially a frictional force between adjacent layers of fluid as the layers move past one another. In an ideal fluid, there is no viscosity to hinder the fluid layers as they slide past one another. When viscosity is present, the fluid layers have different velocities. The viscosity can be measured by using Newton's law of viscosity. Next, the rate of flow in a fluid in a round tube depends on the viscosity of the fluids, the pressure difference, and the dimensions of the tube. Now, how about the volume flow rate? The volume flow rate is proportional to the pressure difference, inversely proportional to the length of the tube and to the pressure difference, and proportional to the force power of the radius of the tube. It can be measured by using Bernoulli equation. Application. So, on the left, we have water and honey. As we know, when we pour water, it flows quickly and smoothly. It is because water have low viscosity. The viscosity of water can change with temperature as the temperature decreases, so the velocity increases. However, honey, when we pour honey, it flows very slowly and with high resistance. It is because honey is highly viscosity. So we can conclude that viscosity of a fluid depends on its composition and the number of particles it contains. On the right, we have blood clot. Blood clot comes from in our body due to very high viscosity of the blood, which can help to prevent excessive bleeding and form a scab. But in some cases, the viscosity of the blood can lead to blood clot, which could potentially be fatal. So, maintaining a balance of viscosities is important for our health.
Now, let's move on to examples. Engine oil passes through a fine 1.8 mm diameter tube in a prototype engine. The tube is 5.5 cm long. What pressure difference is needed to maintain a flow rate of 5.6 mm per minute? We have to write out all the information given from the question. By using Poiseuille's law, we can find the pressure difference. So the answer for this question is 4 multiplied 10 power of 3 Newton per meter square.
Next, what is Poiseuille's law of flow in tube? The law of Poiseuille states that the flow of liquid depends on the following variables, such as the length of the pipe, radius of the pipe, pressure gradient, and the viscosity of the fluid, in accordance with their relationship. The formula known as Poiseuille's law states the four-laminar flow of a fluid, which is liquid or gas, along a pipe, is equals to V, the flow rate, equals to pi, multiplied with the pressure gradient between the two ends of the pipe, multiplied with the radius of the pipe, power of 4, and divide them with 8 multiplied with the viscosity of the fluid, multiplied with the length of the pipe. After that, what is Poiseuille's law function? Poiseuille's law states that flow through a tube depending on the pressure difference between one end and the other end, the length of the tube and the radius of the tube, as well fluid viscosity. When the pressure difference is double, then the flow velocity increases and also doubles. When the pressure difference is double, the flow velocity is also double. Flow is inversely proportional to length and viscosity. When one of them is raised twice, the flow rate will be reduced to half. Speed of the flow increases as the radius of the tube increases. History of Poiseuille's law. Jane Leonard Mary Poiseuille. Some claim that he was the first to measure blood pressure using a mercury manometer, and he utilized connecting tubes filled with water that had been bicarbonated with soda to prevent clotting when he measured the blood pressure of horses and dogs. Then, what is application of Poiseuille's law? Hemodynamics is perhaps the most often used application of Poiseuille's law. Poiseuille's law is used to explain how constricted capillaries increase blood pressure because the volumetric flow rate is so sensitive to changes in cross-sectional area. The heart works harder to raise blood pressure and maintain blood flow regardless of a slight vein restriction that will limit the blood flow rate. This explains the connection between vascular constriction and increased blood pressure. Of the example of Poiseuille's law is blood flow. If the radius of the artery is only half what it should be, the pressure must rise by a factor of 16 in order to maintain the same flow. The heart often cannot beat so quickly, but while it attempts, blood pressure rises.
To conclude this chapter, you have now known what is fluid motion and continuity equation, Bernoulli's equation and its application, viscosity, and Poisson's law or flow in tubes. I hope this helps you a lot. Thank you for your cooperation.